let's look at problem number 10. If we look at number 10, once again, we see that we have the reactants, but no products. So we have to determine what type of reaction am I looking at. And since I have two compounds, I know I'm looking at a double replacement. So each of these is going to switch their partners. And if we write our first pairing, we'll see that calcium is now going to pair with nitrate. So we have Ca and NO3. Another thing we have to be careful about is they're both ionic, so they both have charges, and we need to check those charges. So calcium has a +2, and NO3 has a -1. Now you don't have to write these. This is in case you can't remember it. Since their charges aren't equal and opposite, we have to swap them. So that calcium is going to give that nitrate a 2. Our second pairing is going to be silver with chlorine. And once again, that is ionic, so we need to check the charges. So silver is a +1 and chlorine's a -1. So they're equal and opposite, so no subscripts required here. Next, we're going to have to balance our formula. So Ca, there's 1 on this side, so that's perfect. Chlorine, there's 2, but there's only 1 here, so we aren't balanced. And if we continue to look, we'll see our silvers, there's the same amount on each side, but our nitrates aren't balanced. So I like starting with the polyatomics here. I have 2 nitrates. I want to make 2 nitrates over here, so I'm going to put a 2 over here. And then we needed to balance our chlorine, so we had 2. And so in order to get 2 here, we're going to put 2. In both of the situations, this affected our silver. So I have 2 silvers, but luckily here now I have 2 silvers also. And our calcium remains balanced. So now we have a completely balanced equation. We can solve our problem. Our problem says if 5 moles of calcium nitrate are needed, how many moles of calcium chlorine must be used? Okay, so this is asking what do we need to start with, but we still work about it the same exact way. This is what I want my ending to be. Okay. And we're looking at what do we have to start with? But it works the same way. I start with what I'm given, and then using a mole ratio, I'm going to find the answer to this. So I'm going to take my 5 moles of calcium nitrate, and we're going to put that over 1, and then I'm going to set up my mole ratio. So here, same as before, if moles of calcium nitrate are on top, then that's what's going to have to go down here, because I want to cancel it out. And then on top is going to go the moles of whatever I'm looking for. So I'm looking for moles of calcium chloride. And I'm going to write that up here. The next, we look at our equation to figure out how many moles do we actually have of each. And since there's no number here, we have 1 mole of calcium chloride. And for calcium nitrate, we also only have 1 mole. So it's a 1-to-1 relationship, which basically is telling us that they're equivalent to each other in the amount of moles. So if I did 5 times 1 divided by 1 times 1, we're still going to get that 5. So I get 5 moles of calcium chloride.